Welcome to Economics. Today we are going to study about savings and most probably indices. In last class we saw how to calculate GDP using three different methods. The most popular method or the method that we are going to use is the expenditure method. Using the expenditure method we calculated GDP as C plus I plus G plus net exports. Net exports can also be written as export minus import. So basically this is the equation that we derived using expenditure method in last class. So today we are going to use this equation and most probably expand it to make national income. Basically, in the definition of GDP, GDP was the final value of all the goods and services newly produced within the economy or within a country. But when we talk about the national income includes the final value of all the final goods and services newly produced by the residents of a country. So it means if resident of a country is producing some goods or maybe some services in another country, in a foreign country, then that will also be included in our national income, which is excluded while calculating GDP. So it means there must be some additions in GDP and some subtractions from the GDP to calculate national income. So if we are paying to a foreigner who is producing in our country, then we say it is basically factor payment to abroad. But if we are paying, if foreigner is paying to our domestic producers or a resident, then it means factor payments from abroad. Factor payment from abroad. And the net summation of these two terms is known as NFP, net factor payment, which is basically nothing. If we subtract factor payment to abroad from factor payment from abroad, then we get net factor payment. Basically, this is 1, this is 2, NFP is 2 minus 1. That is, we have to subtract factor payment to abroad from factor payment from abroad. Factor payment from abroad basically means our domestic residents are earning or maybe producing some goods in a foreign country. And factor payment to abroad basically means foreign residents are producing or earning some money in our country. So basically we have to calculate the net factor payment for our analysis of national income or calculation of national income. So it means national income is equal to GDP plus summation of net factor payment. If we sum the net factor payment to GDP, then it turns out to be national income. Now this national income can be divided into two parts. First part is the private income and second part is government income. So whatever portion of the national income goes to private sector, that is known as private income. And whatever amount of income which is not available to private sector for their disposal, it means government income. Here by private income we means private disposable income. So private disposable income is the amount of income one has available to spend after reducing taxes and other deductions. So basically it means whatever amount of money that you have at your disposal to either spend or save after reducing taxes or other deductions. That is known as private income or private disposable income. Similarly, whatever amount of income which is not available to the private sector, which is not available to private sector at their disposal, is known as government income. In terms of equation, private income is basically Y plus net factor payment from abroad plus transfers from government plus interest payment, and we subtract taxes from it. First term is income, that is GDP. Second term is net factor payment from abroad. Third term is transfers. Transfers are like subsidies that a particular consumer receives from government. Government sometimes provides different kind of transfers to private households or the private sector. For most popular transfer is subsidies. Then another term is interest. Interest is basically the cost of borrowing fund. So whenever government borrows from private sector, it has to pay some interest on that particular fund. So that particular interest rate that government pays on borrowing is known as interest rate, which goes to a private sector. Therefore, we add that to private disposable income. And finally, we have to subtract taxes that a private sector pays to government. So this particular equation is private disposable income. From the government side, government earns taxes. So we write taxes. But government has to shell out some amount from these collections of taxes. First is the transfers. Transfers means like subsidies. Then government pays interest on borrowing. So therefore it has to be subtracted from taxes. So this sum is government income, and this equation shows the private income. If we are going to sum these two, then we will get national income. So basically national income is summation of private income plus government income. Let's do the summation. So private income is Y plus net factor payment from abroad plus transfers plus interest payment to private sector and minus taxes. And now plus government income, which is taxes minus transfers minus interest payments. So here transfers will be cancelled out, plus minus, same goes for the interest rate, and same goes for the taxes, which turns out that national income is equal to Y plus NFP, as we saw earlier, that our national income is equal to GDP plus net factor payment from abroad. Same exactly, Y plus NFP. So basically, suppose in exam you have to calculate private income, and you solve this equation, and you are confused that whether my answer is right or wrong. Then basically you can do this summation of private income and government income. If you get Y plus NFP, then it means your equation is right and correct. In this way, you can remove your confusion. So apart from national income, there is a related concept of savings. So what is saving? Saving is the surplus amount that remains with a consumer after spending on goods and services. For example, if you have 100 rupees at your disposal and you spend 80 rupees on it, then the remaining surplus amount of 20 rupees can be termed as savings. So again, as we saw that national income can be divided into two parts, private income and government income. In similar way, savings can be divided into two parts. The first is private saving and another is government saving. First we will write down savings is equal to income minus expenditure. In our example, income of a consumer was 100 rupees and expenditure 80 rupees, and whatever the remaining amount, surplus amount, 20 rupees can be termed as savings. So again, these savings can be divided into two parts, government saving and private saving. In terms of national savings, or simply instead of saying national savings, we can simply say savings is equal to income minus expenditure so savings can be termed as equal to income minus expenditure. Now this particular saving, just like income, has two components, government saving and private saving. Suppose we want to calculate private saving, and what we have to do? Basically, we have to subtract from private income, we have to subtract private expenditure. So private income was Y plus NFP plus transfers plus interest payment from government, and then we subtract tax payment. And private expenditure is nothing but basically C, that is consumption expenditure, minus C. So this term is private saving. In terms of government saving, we have to subtract government expenditure from government income. So government income was taxes minus transfers minus interest payment, and government expenditure is nothing but exactly G, that is government expenditure, that we used to consider in calculating GDP using expenditure method. So minus G. This particular term is nothing but government saving. So this term is, this equation shows private saving and this equation shows government savings. So to calculate national saving, basically we can do summation of these two. If we if we do summation of private savings plus government savings, then we will get national saving. Let's do it. So basically national savings is equal to private saving plus government saving. Here you might be curious, then what do we mean by government savings? So basically just like the private sector savings, government can also save. Basically, when will government save? When in receipt of government is more than its expenditure. But generally we observe the opposite happens. That is, in real life or in current scenario, the expenditure of government is more than receipt. So basically it means government is doing negative savings. Savings are in negative terms. In other words, we know it as government deficit or budget deficit. So national saving is summation of private saving and government saving. Let's substitute the value of private saving and government saving from these two equations. Basically what we are doing in this new equation, national saving equation, we are substituting the value of private saving and government saving. Private saving is this and government saving is this. Private saving is Y plus net factor payment from abroad plus transfer plus interest payment minus C. And for government saving, it is T minus transfers minus interest payment and minus G, which turns out Y plus NFV. Here transfer is the plus, here is negative, this will get cancelled. Similarly interest payments, so minus C and minus G. So national saving can be termed as Y plus NFV minus C minus G. So here we can expand this equation as well. Basically here we can substitute the value of Y from the equation of GDP. If you remember, we used to write GDP as C plus I plus G plus NX. So simply we can substitute the value of Y from this equation. So let's substitute the value of Y here. C plus I plus G plus NX plus NFP minus C minus G. C will get cancelled out. Similarly G. So savings is equal to I plus net exports plus net factor payment. If you will look closely, these two terms together, net exports plus net factor payments, these two terms make up for our current account. So we can rewrite this particular equation as saving is equal to I plus CA, that is current account. So basically what it shows, this particular equation shows that national saving can be utilized in two ways. National savings can be used and utilized to invest in our economy, and second usage is to balance our current account. What do we mean by balancing current account? Basically in current account, we means by using our additional savings, either we can lend to foreigners or we can purchase assets in foreign country. Basically what happens, whenever we export more goods to a foreign country, our earning of foreign exchange is more than our expenditure of foreign exchanges. So in that case, if a foreigner want to import anything from us, then they have to either borrow from us or either they have to sell their assets to us. See, in whatever case, in the first case, we are lending to a foreigner. In the second case, we are purchasing their assets. So basically, national saving can be utilized either to invest in domestic economy, or the second way, we can either lend to foreigner or purchase assets in foreign country. That is current account. But in exams, from exams perspective, usually in the exam they ask what are the uses of a private savings. So therefore, we will see what is the usages of private savings. So saving is equal to I plus current account CA. If we subtract government savings from both sides, saving minus saving of government, I plus CA plus minus government savings, then it turns out to be private saving is equal to I plus CA minus savings of government. This term minus government savings can be rewritten as plus in bracket government savings. This equation shows that private savings. This equation shows that private saving can be utilized in three ways. First, it can be utilized to invest in domestic economy, that is investments. Second, it can be utilized to balance our current account. From current account, there are two components. First is lending to foreigners. Then another is purchase of foreign assets. And third, the private saving can be utilized to finance negative government saving. What do we mean by negative government savings? It means budget deficit. It means private saving can be utilized to finance budget deficit. Usually in exams, they ask about the usage of private savings. So in case they are asking for private savings, then basically you have to derive this equation and then show the different usages of private savings. After private savings, there is a related concept of savings and wealth. Usually saving and wealth are interlinked and related. Basically, saving is a way to generate your wealth. Basically, these two terms are different terms. Saving is a flow term and wealth is a stock term. And what do we mean by stock and flow? Any variable which is measured at a point in a time is basically a stock variable, and any variable which is measured per unit of time is a flow variable. So generally, whenever we ask about savings, we usually ask how much amount do you save in a week, or how much amount do you save in a month. So basically we are asking in a period of time. Or we can also say unit of time. Generally we ask what is your monthly income, or if the wage is paid hourly, we ask what is wage hour. But whenever we ask wealth, usually it means at that particular point of time, we are asking right now how much wealth do you hold. So it means it is always measured at a point of time. For example, you might be saving 100 rupees daily, then that is savings 100 rupees per day. But whenever we ask about the wealth, how much amount of wealth do you have? maybe you have a digital gullak, or maybe you have a physical gullak. So whatever amount of money that you are holding in that particular gullak can be termed as your wealth, and always it will be measured at a point of time. For example, if I ask you कि अभी कितने पैसे हैं, how much amount of money do you have right now, then you will measure it in a point of time. So this is wealth and this is savings. Saving is a flow variable and wealth is stock variable. So if you want to generate wealth, then basically we have to increase the flow variable. For example, suppose there is a water tank and you want to store maximum amount of water that you can have. Here is a tank and you want to fill up to the brim, and here is a pipe connected to it which is dumping water to this particular tank. So basically this is your savings that you are dumping to generate wealth. If there is a more inflow of water, then this particular water tank will fill very fast or within a short span of time. And if the flow of water is very slow or infrequent, then this particular water tank will be filled in a long run or in a very long period of time. It will take lots of time. So in the same way, if you want to generate a particular amount of wealth, then you have to increase your amount of savings so that you can save more quickly. Now let's talk about a GDP in terms of real GDP and nominal GDP. So we were talking about GDP and we were writing it as GDP is equal to Y is equal to C plus I plus G plus net exports. Here when we were talking about GDP, here by term GDP we meant nominal GDP. Here this GDP was nominal GDP. And there is another term which is known as real GDP. Now you might be wondering, what is nominal GDP or what is real GDP? So basically any variable which is measured in terms of current prices, then it is nominal. And the whatever variable, if it is measured in terms of base year prices, then it is real. So if GDP is measured in terms of current prices, current market prices, then it is known as nominal GDP. If GDP is measured in terms of base year prices, then it is real GDP. That's the main difference between the prices. So basically in real GDP, we use base year prices, and in nominal GDP, we use current market prices. So if you remember, in the definition of GDP, we were saying GDP is the market value of all the final goods and services newly produced within the country. So here by market value, we meant current market values. So basically it was nominal GDP. But if we use, while calculating the GDP, if we use base year prices, then it will be real GDP. In terms of definition, we can say nominal GDP is the market value of economics final output measured at current market prices, while real GDP can be termed as value of an economist's final output measured at base year prices. So whenever we talk about base year, current year, or current prices, base year prices, then there is a terms that is known as index. Usually we talk about indexes whenever we are doing or whenever we are comparing to different price levels. So basically we can define price index as, so price indexes can be termed as measure of the average level of prices for some specified sets of goods and services related to the prices in a specified base year. So in the definition, what we are talking about, measure of average price levels of some specified goods and services. So first we are specifying some particular goods and services, that these particular goods and services will be included. If there is a particular good or services which is outside this bundle, then we are not including or considering that particular thing. only those specified goods and services are considered. So in the price index, we are considering only specified goods and services, and we are monitoring the prices of these particular goods and services from base year. If there is an increase in price level, then simply price index will reflect that increase in the average price level of these specified goods and services. So basically, as we defined, nominal GDP is different, real GDP is different. Real GDP is the market value of all the final goods and services newly produced when measured in terms of base year prices. So there must be difference between nominal GDP and real GDP in terms of a formula. So we calculate real GDP as nominal GDP divided by GDP deflator divided by 100. If we divide nominal GDP by GDP deflator divided by 100, then basically we will get our real GDP. So it means real GDP and nominal GDP are interlinked by a variable which is GDP deflator. Now you might be curious, then what is this GDP deflator? So GDP deflator is nothing but it is a price index that measures the average level of prices of all goods and services included in GDP. So as we saw the definition of a particular price index, it measures the average price level of a specified goods and services. So here GDP deflator is a price index which is measuring the average price level of specified goods and services. Then here what we have specified the prices of those particular goods and services which are measured in GDP. Here GDP deflator is nothing but a price index which measures the average price level of all the goods and services which are included in GDP. So if we want to calculate GDP, then here we can, using this particular equation, we can calculate GDP deflator. GDP deflator is equal to nominal GDP divided by real GDP into 100. This particular equation shows GDP deflator. GDP deflator is very important terms because it shows the actual rise in the production level of economy. I will give you an example to make it more clear. For example, suppose in year 2025, you are manufacturing 10 cars and 20 food packets. Price level is 1000 and price level of food packet is rupees 10. So if we want to calculate GDP in year 2025, then it may turns out to be 10,000 and 200. The final value of all the final goods and services produced in this economy in year 2025 is rupees 10,200. But now suppose in year 2026 we are still producing 10 cars and 20 packets of food. But due to inflation, price of car doubles to 2000 and food packets doubles to 20 rupees. Then if we are going to calculate GDP, then it may turns out to be 20,000 and 400. So in monetary terms, it may look like from year 2025 to year 2026, the GDP of this particular country or economy has doubled from 10,200 to 20,400, which is very mischievous, because in real terms we are still producing 10 cars and we are still producing 20 food packets. So in real terms, in terms of physical goods and services, the economy in year 2025 is equivalent to economy in year 2026. But in monetary terms, it looks that GDP in year 2025 in 2026 doubles. So that's why we usually use the term GDP deflator. To deflate the economy, which has risen due to inflation, and to have a real picture of our economy, how much physical goods that we are producing. Then it means in a nominal variable, there are two components. First, increase in output, and second is increase in price. So suppose a particular nominal variable is increasing, then it might be increasing due to two reasons. First is there is indeed increase in the level of output, or second, it might be rising basically due to increase in the price levels. In our example, nominal GDP was rising just because of increase in the price levels. Here increase in output level was exactly 0, but in terms of price level it was 2x, and due to this phenomena our nominal variable was increasing 2x. That's why this shows the importance of GDP deflator while calculating GDP. Apart from GDP deflator, there is another important index that is known as CPI, Consumer Price Index. So basically, just like another index, CPI is nothing. It is also a price index which measures the average level of prices of consumer goods. By here, consumer goods means consumer goods is generally a fixed basket of goods and services that government includes for the purpose of calculating inflation. There might be various flaws while opting for this fixed baskets, but we won't go to that debate. But when we're talking about CPI, Consumer Price Index, it includes consumer goods, which is basically nothing but fixed basket of goods. Fixed basket of goods, which is very basic and necessary for a individual's living. You may consider it as a shopping cart that you purchase monthly for your survival. Basically, it includes some amount of food products, some amount of clothing, some amount of fuel, and other basic things. But generally, whenever we calculate CPI, then there might be different kind of bias while calculating GDP. What kind of bias can be there? First kind of bias is quality bias. What do we mean by quality bias? In terms of price index, suppose a particular product has price level of 100 rupees in year 2025. In next year, suppose price level of this particular good rises to 110s. Then using the CPI, it may show 10% inflation. But this rise in price level of particular good can be due to rise in the quality associated with it. For example, if there is a particular new AC launched in year 2026, which is 10% more efficient, then basically this 10% increase in price level reflects the rise in efficiency of that particular good. Then in terms of CPI, basically in terms of CPI, whatever amount that we show that the particular good rises by 10%, it is very dubious. In same way, there is another bias which is known as substitution bias. Sometimes we have very close substitutes of a particular good. For example, Pepsi and Coke. Suppose government includes Pepsi in your CPI bundle while calculating CPI. But generally what happens, eventually the price of Pepsi rises. Then usually what we do, we substitute a cheaper good. Then consumer will shift to Coke because both goods are very close substitutes. Eventually what will happen, consumers are consuming Coke, which is still selling at old cost, old price, and the Pepsi is selling at new price. But no one is purchasing Pepsi. Most consumers are purchasing Coke at old price. But our CPI shows that due to rise in the price of Pepsi, the average level of CPI is also rising, which kind of very dubious and misleading. So now we will talk about the inflation rate. Inflation rate is nothing but increase in the percentage increase in the average price level in the economy. Inflation rate can be calculated using GDP deflator. Deflator T plus 1 minus deflator T divided by deflator in period T. So let's take an example. Suppose in year T plus 1, GDP deflator rises to 105 and in period T it was 100. Then our inflation will be 5 upon 100. In percentage terms it will be 5%. Now suppose in a third year GDP deflator rises to 112. Then our inflation rate will be 112 minus 105 divided by 105 is equal to 7 upon 105, which may turns out to be 6.66, okay, 666% or maybe 6.67%. So basically what we are doing, we are basically subtracting GDP deflator in year T from GDP deflator in year T plus 1, and we are dividing whole thing by GDP deflator in period T. If you get confused by using these terms T plus 1, deflator, etc., then maybe you can use a simpler version where inflation rate can be written as price level in period T plus 1 minus price level in period T divided by price level in period T. So basically this turns out to be our base year and this turns out to be our current year. So that's how we calculate inflation rate. Then after this inflation rate and GDP, next thing is about interest rate. What is interest rate? Basically, interest rate is nothing. It is the cost of borrowing a fund from market. If you are borrowing anything, then you have to pay some cost to it, some cost for it. So for money, you have to pay some cost. It is known as interest rate. Suppose I want to borrow 100 rupees from you. Then you may ask me, so what will I get in return? So basically, I have to promise you something in return of borrowing that particular 100 rupees. So I may say, okay, let me borrow 100 rupees right now. In next week, I will return you 102 rupees. So I am promising something extra for borrowing that particular fund, and that particular extra thing that I am promising to give you is known as interest rate. So interest rate can be therefore term sides rate of return promised by a borrower to a lender, or in simple terms, it is cost of borrowing the money. So again, as we saw, GDP was divided into two things: real GDP and nominal GDP. In same way, interest rate can be also studied in two parts, that is real interest rate and nominal interest rate. So real interest rate is the rate at which the real value or the purchasing power of an asset increases over time. Basically, it is showing increase in the purchasing power of an asset over the time, while nominal interest rate is the rate at which nominal value of an asset increases over time. So if we write it is showing rise in nominal value of an asset. But real interest rate it shows increase in purchasing power of an asset. In terms of equation, real interest rate is interest rate I minus pi, which is nothing but inflation rate. So if in the nominal terms we subtract inflation rate, then we get our real interest rate. Which shows the actual increase in the purchasing power of particular assets. Let's take an example. Suppose there is an asset whose current value is rupees 100. Now suppose nominal interest rate is value of asset is 100 rupees and nominal interest rate is equal to 100. Nominal interest rate 5%. Then using the nominal interest rate thing, it shows rise in value of assets from 100 to 105. Now suppose during this particular 1 year, inflation rate was also 5%. Then it means it shows earlier whatever amount of goods and services that we were able to purchase using 100 rupees, now to purchase same amount of goods and services, now we have to shell out 105 rupees. So in real terms, here we have 0% appreciation of assets. 0% appreciation of asset. Why? Because real interest rate is equal to I minus pi, which is 5% minus 5%, which is exactly equal to 0. So our real interest rate shows increasing the purchasing power of an assets. So here, if nominal interest rate is 5% and inflation rate is also 5%, then in real terms, there is no appreciation in that particular asset. So that's why it's very important to include inflation while considering the investment of your assets. For example, right now, usually households save their money in fixed deposits, which promises a return of around 6% to 8%. But the current inflation rate in the economy is already 6 to 8%. In some segments, it is more than 10% or 12%, especially in the food segment. So what is happening to your money? Basically, by investing your money in FD, basically you are eroding the purchasing power of your money. So that's why it's not a very wise decision to invest your money in fixed deposits. And while talking about interest rate, there is another term, that is the expected real interest rate. So basically what happens, the nominal interest rate is generally known in advance. For example, whenever you are going to book your FD, or in case you are lending to someone, exactly at the start of period, you know nominal interest rate. It might be 5%, 10%, 20%, depending on different factors. But as we saw, the real interest rate is the major variable that we should consider while undertaking investment decisions or borrowing decisions. But to calculate real interest rate, we have to subtract, we need to know about nominal interest rate, which we know here, that's okay. But we also need to know about the inflation rate, that is pi. But during the start of period, at the time when you are initiating a borrowing decision or a lending decision, you don't know what is the exact inflation is going to happen in your economy. So basically what we can do, basically we can just expect, or we can estimate the inflation rate. So basically you are making a guess, or you can say you are basically making a gamble. Why I'm saying gamble, it will become more clear. Suppose you have 100 rupees and there are two persons. One is the lender and another person is borrower. This particular person A want to lend them 100 rupees and particular person B want to borrow this particular 100 rupees. Now both know that the inflation, that nominal interest rate in the market is 5%. So if person A is going to lend 100 rupees, then he will get 5% as the rate of interest, and borrower knows that if he is going to borrow this 100 rupees, then he has to pay 5% as interest rate. So, but real equation comes in when we consider inflation rate. At this point of time, both of them don't know what is going to be the inflation rate in the economy. So both A and person B makes an educated guess that this XYZ percentage is going to be inflation rate. Suppose person A thinks inflation rate will be only 2%, while person B thinks the inflation rate will be 8%. So usually there is a law which says that if inflation rate is greater than expected inflation, then borrower benefits. And if inflation rate is less than expected inflation rate, then lender benefits. So now he's expecting the 8% inflation rate in the economy, and lender is expecting 2% rate in the economy. So basically, what he expects that at the end of 1 year, I will get back 105 rupees. And if inflation rate is exactly 2%, then in terms of real interest rate, he will get 3%. But if inflation rate turns out to be 8%, then in real terms, he have to shell out minus 3%. Let me make it more clear by using exactly the particular equation. So basically real interest rate is I minus inflation. So here I is 5% minus 2%. If equation turns out to be 2%, then in real terms he will get 3% as real interest rate. But if inflation turns out to be 8%, then again real interest rate is equal to nominal interest rate minus inflation is equal to nominal interest rate is 5% minus inflation rate is 8%. So basically here the real interest rate is minus 3%. It means if the expectation of lender is right, then he will gain 3%. He will earn an additional amount of 3%. But if the prediction of borrower is right, then the borrower will gain 3% and the lender will lose 3%. So that's why all this calculation of real interest rate, nominal interest rate depends on inflation. And in the current period, we don't know the exact amount of inflation. So we all make educated guess, and as per that guess or that expectations, we make borrowing or lending decisions. So again, I will just repeat. If current inflation rate is greater than expected inflation rate, then borrower benefits. And if current inflation rate is less than expected inflation rate, then lender benefits. Okay, now see you in the next class. If you have any doubts, then basically you can ask in comment sections. We will answer your queries. Thank you.